absolute value equations. Let's go ahead and get started with problem number 1. So the first thing we want to do is put a temporary vertex right at the origin. We're going to end up erasing this point after we move it to where it needs to go. All right, now if we add or subtract directly to our variable, that moves us left or right. Now if we specifically add, that's going to move us left. So it's left 1. This is sometimes backwards of what you would think. Sometimes it feels like adding should move us right, but this one I just remember it's backwards, and that's how I remember it. So this point's no longer here, it's moved over here. All right, if there was anything at the end, we would move it up or down, but there's not. So now we got to figure out what the slope should be of this V-shaped graph. There is no number in front, so we could fill a 1 in there without changing the problem, and that should be our slope going to the right. So go to the vertex and attach a slope of 1 going to the right of that vertex. That means go up 1, right 1, up 1, right 1, up 1, right 1, all the way until you're off the graph. Connect these up and draw an arrow, but don't continue it on this way. It just starts at the vertex. Sometimes even like to label this the vertex. And then continues on to the right. For the left of the vertex, it flips, the slope goes from being positive 1 to negative 1. So we go up 1, left 1. And that's where the V shape of the graph comes from, is from the fact that it bounces at the vertex here before going up this way. All right, and so these two lines here, connected at the vertex, represent all of the points that would make this absolute value true. So if I test a point like this point right here, which is at -3, 2, all right, it should make this equation true. So 2 equals the absolute value of -3 plus 1. 2 equals the absolute value of -2. And we know that the absolute value of -2 is +2, so 2 equals 2. That's a true statement. So that's a good sign that we have graphed this one correctly. All right, let's try problem number 2 here. So again, temporary vertex at the origin. This -2 here, so it's the opposite of this +1 moving us left 1. This is going to move us right 2. So here's our new vertex. It doesn't move up or down. This negative in front we could replace with a -1, and that is the slope going to the right. So down 1, right 1, down 1, right 1, down 1, right 1. All right, but it doesn't continue this way. It bounces, so now the slope going to the left is +1. You can fill in those points, and then check with a point. That's the graph for number 2. All right, let's look at number 3, because that does have a vertical shift. We see this +2 at the end. This -4, that's going to be a right 4. And then this +2 is going to move us up 2. So right 4, up 2. So this is where the vertex was, but it's moved right 4, up 2. Here's where it is now. The slope going to the right is 1. I like to see those points bolded in, so I should do it. And then the slope over here is reflected. All right, let's do, I guess, problem number 5. What is that +3 going to do? So it can move us left or right 3. You said left 3, you got it right. And then this -1, is that going to move us up or down 1? You said down 1, you got it right. So vertex was here at the origin, but it moved left 3 and down 1, so here's where it is now. This point's now gone. And then the slope going to the right is -1, so down 1, right 1, down 1, right 1, down 1, right 1, all the way across the graph, and then reflected over here. All right, so I should see 6 different V-shaped graphs for these. And then I threw in just a couple solving, just to remember how to do these. Let's do problem 8. So once I've isolated the absolute value brackets, I want to split it into the positive and the negative case. I'll even label it positive case, negative case. In the positive case, this value is positive and the brackets don't have a job to do, so they leave this quantity alone. In the negative case, they need to flip it back to being positive, so they multiply everything by -1. All right, and that's how we can get 2 answers, because of the positive case and the negative case. All right, let's finish solving this over here. We add 5 to both sides. We get x equals 15. Over here, we distribute that negative. We get 5 minus x equals 10. Take away that 5. Negative x equals 5. Divide by negative 1. X equals negative 5. And then you need to test these because you can get extraneous solutions. Let's just do it out loud. Negative 5 plus 15 is 10. The absolute value of 10 is 10. 10 equals 10. This one checks out. Negative 5 plus negative 5 is negative 10. The absolute value of negative 10 becomes positive 10. 10 equals 10. This one checks out. All right, and there's a quick peek at the answer key. Have a good rest of your day.